Closures versus factories. Closures versus factories. Can you have a factory that doesn't use a closure? I spent ages Googling about this. I wanted to see a distinction between what a closure was, what a factory was, and see them working on their own, and then see how you can combine them together. I couldn't find an example, so I thought, why not make a tutorial that shows the difference between the two? Obviously, I've had to do some research, and so we'll get straight into the first example starting now. So this is an example of a factory function which does not use a closure. A factory function is any function that returns an object. To return objects, we put the values between curly braces, as you probably already know, and that means we can access the contents of the object using dot notation. Just here, this little dot. The reason this is useful is because we've got one function, which is this player factory, and any variables that we declare inside the function, we don't want to have to declare multiple times every time we want another player. So by having a function that contains all these variables just once, it means we can make as many copies of that player factory as we want. So in this case, we've just got the two, player 1 and player 2. Each of those instances has got its own copy of score and lives, which means we can update them independently. We've also got name, I nearly forgot to mention. I would typically put name inside the function just here. Now we can check to see if this has got a closure by clicking on these little right arrows, and you can see there that there's nothing associated with the contents of the object that indicates there is a closure. You'll see in just a second an example of a closure, and whereas you can see prototype now in these yellow square brackets, you'll see scopes within these yellow square brackets, and within the scopes is where we will see a closure when one is created. So there's definitely not a closure associated with this object. And you might be thinking, that's obvious, Gary, because we haven't got a function inside a function. And it's true that that's the best example to demonstrate a closure. But you can have a function inside a function, you can return some useful information, you can have that useful information that's returned, update the values that are declared inside out a func, in this case it's called player factory, and you still don't have to have a closure, and I'm going to show you that next. So this is a function that we're going to add, and so we can call the extra lives function to update the value of lives, but we can't do it directly within the method, but we can do it externally after returning a value. So we do that just here. Passing in the value of 7, we then generate a random number from 0 to 7 on this line just here, and return the result and use that value to update player2.lives. So let's click save. We need to add extra lives to the returned object values, so we need to add that in just here, and now let's click save. There we go. Player2.lives starts out at value 5. We can see that it's now 7, so let's click the open arrow to see if we've got any closures. We've got a function which we can open. We can see that lives is 7 just there and just there. Let's open the extra lives function. When I mentioned before that we would see scopes between the yellow square brackets, we can see that we've got them now. And within scopes, let's open that up, and we can see that we've got a script scope and a global scope, no closure scope. If there's a closure, you'll see the word closure there. We can see script, we can see global, but there's no closure. So just the two scopes. Let's open up the script scope, within which we've got our global variables, which are the variables within script scope. That's confusing because you've got globals there, but they are within the script. It's global to the script. So to recap then, we've got a factory which returns 4 values, which are name or my name, score, lives, and the method extra lives. And we are returning some useful information from the extra lives method and using that to update player2.lives value, as we can see just there. And we can do all of that from the factory without using a closure. So what does a closure bring to the party? Let's have a look. And let's click save. There we go. When I started to research closures for this tutorial, I came across examples pretty much the same as this one quite often, and for the life of me, I could not understand how this was supposed to help me understand what a closure was. My understanding at that point of what closures were it meant we could retain the state of variables as declared inside an outer function. So if one func, being the most parent function, was considered the outer function, then we would also have an inner function, and therefore the state would get retained for any local variables which are declared inside the outer function. And so after one func has finished running, we would somehow retain the value of myval. And that's not what's going on here. Just to quote MDM Web Docs, a closure is the combination of a function bundled together with its surrounding state, the lexical environment. Well, we can ignore that for now. In other words, a closure gives you access to an outer function scope from an inner function. We haven't even got an inner function. So I don't think this example is a good example, but I just wanted to show you it to demonstrate that technically speaking, it does produce a closure. As I've put in the notes just there, Chrome DevTools used to, about 7 years ago, I saw a 7-year-old tutorial before Google had updated their Chrome DevTools, I expect it must have been, and it used to associate globval, as we've got there, would have been associated with one func as being within a closure. It doesn't do that anymore, but it used to 7 years ago. They've obviously changed it, but let's click on the right arrow and I'll show you where it should be. So within scopes, we've only got 2. 7 years ago, within this section just here, Google Chrome used to show globval, as we've got there, associated with one func, and scopes would have said either 2 or 3, but one of them would have been closure. So you don't need to have a function inside a function to have a closure. Just by having a function, you've got a closure. And so this was just a way of proving that. But as a practical example, it's not a great example. So let's move on to the next example. And let's click save. Isn't that beautiful? 1 2 3 1 2 4 1 2 3 1 2 4 1 2 3 1 2 4. The reason that that's beautiful is because look at what's going on. We have got a function inside a function. It's not a factory, as I've put there. It's not a factory because we're not returning an object. Look at the return statement there. You can't see little curly braces either side of increment, so we're not returning an object, we're just returning the increment function or the increment method. So thinking back to the MDN Web Docs definition of a closure, which I quoted in the last example, according to that, increment has got access to the count variable via a reference. The increment function just here has got access to the letCount variable through a reference. But what is a reference anyway? What do we mean when we talk about something having a reference? The value itself is in memory somewhere, and if we've got a reference to that memory location, it means that we can update that value. The increment function, which has been given a reference to count, can therefore update that existing value. There isn't a copy of count that's being created, it's just that one copy that is declared using the let keyword. So a typical cycle would just be to call the counter function. So we would call it from somewhere, so we could call it from just here or anywhere else in the program. And without an inner function or without a closure, once the function has finished running, so once we get to this line just here, it means that letCount no longer exists. But if we can preserve the value by preserving the reference to count, then it means that count won't expire. But how do we do that? Well, closures themselves, when they're formed, they don't expire. So by giving the increment function a reference and then returning that to a variable that's declared outside of the function, so we're doing that just here, we've got letMyCounter1 and we've got letMyCounter2 equals counter, that calls the function runs, the closure gets created because we've got increment as the inner function, and we then return increment, and that returned function gets stored into each of these 2 instances of the function call, counter. Therefore, we've preserved the reference by doing that, and that means that the value of count lives on. So let's take a look in the DevTools to see where those closures appear. We have console.dir myCounter1. That refers to this first increment just here. I'm going to open that, and we can see already that we've got 3 scopes just here. I will open up this little arrow and we can see that we've got a closure scope. It's an association between the counter function and the count variable at value 4. That's because that's where counter 1 finished at, because we have these 3 my counter 1 calls just here, which take it to value 3, and then we have the final my counter 1 call after 2 my counter 2 calls. We call it just one more time at the end just here, which takes it from this value 3 to this value 4. Let's move on to example 4, which is a factory and a closure combined into the one example. So straight away then we can see that we're getting a closure because we've got outer func just here, and we've also got inner func 1 and inner func 2. The question is, what is going on with variables A and B? Before we go any further, let's have a look and see what the closures look like inside the DevTools. We can open up either of the functions. Let's open up inner func 1, and we can see that we've got 3 scopes, and we can see we've got a closure, Derek Edward just there, Rodney Charlton Trotter. At the top though, we've got Derek Edward Trotter and Rodney Charlton Trotter. Why is Trotter missing off of Derek Edward at the bottom in the closure? It's not for Rodney. That is because when we update Rodney's value at the bottom just here, and we add Trotter onto B, B is the reference to the one and only copy that exists of B. Therefore, this value at the top and this value within the closure, they're the same value, they're the same copy of B. So whenever we change one, we're changing the other. That's not the same for A. When we add Trotter onto func A at the bottom just here, we are not changing the let A that we initially declared inside outer func, but we are changing the copy of A that we created by returning A. And that is why Trotter appears just here at the top and why it doesn't appear down there at the bottom. If we want to add Trotter onto the end of Derek Edward, we need to use inner func 2, because inner func 2 refers to the closure copy, the copy that is declared at the top of outer function. We can do that by uncommenting this line. When I click save, we should see Trotter on the end here. Trotter should appear. I'm going to click save now. And there we go. Let's now look back in the closure. Open this up. Open up either of the functions because they both got access to the closure. We'll go for inner func 2. And now we can see that both A and B have got the name Trotter added on. So we're dealing with 2 different copies of variable A and just the one copy of variable B. But because variable B is an object and therefore it gets returned by reference, it means that we can update the value of the closure outside of the function without having to use an internal function such as inner func 2. It's worth noting that even if we don't refer to variables A and B inside inner func 1 and inner func 2, the closures still exist. It's just that they won't appear as closure scopes within the DevTools. And so there we go. That wraps up example 4. Let's move on to the final example. Factory pizza with pepperoni, class pizza with pepperoni. Well, this isn't an example of a factory versus a closure, but I just thought it was worth adding this onto the end of the video just because it seems so directly related. So we've got the factory function in the top half just here, and we have the class equivalent just here. We can see the results are the same, so let's just very quickly go through line by line to see how they are equivalent. The first thing to notice is how the object gets created. We already know that a factory function creates an object by returning the contents within the purple curly braces. And you might already know that we use the new keyword to create a new instance of a class. That's the first difference, how we create the object. Let's now look at the class method. We can see that there's no function keyword, so we've got add topping, and add topping within the factory function uses the function keyword to declare it. We've got the same parameter, topping. Within the body of the add topping function, we are saying mil plus equals topping, and within the body of the add topping function for the class, we're doing the same, but we use the this keyword to refer to the mil, whereas we don't do that in the factory function. Straight away then we can see that we're creating a closure just here, and by creating a closure it means that we are controlling the value of mil in the factory function via another function, the add topping function, just here. We also know from the last example that we need to return the add topping function within the object just here, which then allows us to call it by dot notation just here. When we compare that with the class, again we use dot notation just here because that is also an object that we've created. We just do the same thing, and so that's pretty much it, apart from we can also have a look at the content of the plate lickers 1 object. So let's just type in the name of the object, enter again, and now let's have a look inside just to see if we can see the closure. We've got add topping and show mil. Let's have a look in add topping. We can see that we've got 3 scopes, and within there we can see that we've got a closure, factory pizza. The pepperoni is missing. No, it's not. Let's just open up. There we go. So we've got factory pizza with pepperoni as the closure for factory function. And so with that, that's the end of this tutorial. Hopefully you'll see me next time. Don't forget to subscribe.
Cheers.